In this lecture, we're going to learn about geospatial queries in order to implement a really cool feature, which is to provide a search functionality for tours within a certain distance of a specified point. So let's say you lived in a certain point and wanted to know which tours start at a certain distance from you, like 250 miles, because you don't want to drive further than that in order to start your tour experience. So that would be an awesome feature, and that's actually a really nice use case of geospatial queries. And in order to implement something like this, here in our tour router, we could create a nice route, something like this. So I'm going to put it here before these general routes here. So let's say router.route, and I'm going to call this one tours within. Okay? Then we also need to specify the distance. And so therefore we create a distance parameter here. Next, we also need to specify the center, and so that's basically the point where you lived. So let's specify in our route center and then slash and then lat and longitude. So basically into this variable here, we want to pass in the coordinates of the place where you are. So let's say you lived in Los Angeles and wanted to find all the tours within a distance of 300 miles. So here you would say 300, and then here you would put the coordinates of basically where you live. All right. Then let's also provide the option of specifying the unit. So either if this distance here is in kilometers or in miles. So let's say /unit and then unit as the parameter. Now this way of specifying a URL is something that we never did before. So basically saying here center and then slash and then putting the longitude and latitude after that and then /unit and then after that the query parameter. And of course we could also make it so that the user should specify all of these options using a query string, but this way it looks way cleaner, and it's also kind of a standard way of specifying URLs which contain a lot of options. So what I was saying is that instead we could do it, of course, like this. So tours distance, and then the user would have to provide the distance like this here, then the center like this. So let's say -40 and 45, and then the unit also set to miles. Okay, so this would have been one way using query strings if we have done it before. And actually not like this, but like this. Okay, but instead we will want to specify it again like this, which in my opinion looks way nicer. So -40, 45. Okay. So I think that this here really looks a lot cleaner than this, okay? And so this is also another thing that I wanted to show you, is that it's kind of a standard of specifying URLs like this, all right? Anyway, for this route, of course, we need a route handler, and so that's going to be at tour controller, and let's call this handler function get tours within. And so let's now go ahead and implement this method, so this handler. So tour controller, and right down here, and let's start by getting our parameters. So let me just copy all of this here, just so we know what our data looks like. All right. So this, and then this as a comment. All right. So let's use a simple destructuring in order to get all our data at once from the parameters. And actually we need to say const and distance and unit. So all of that comes from request.params. Okay, so on rec.params we have .distance, .center, and .unit, right? Because these are the names of the 3 parameters that we specified here. And actually it's not center, it's let LNG here. Okay, so that's the correct one. And then finally the unit. Okay, and so again we use the structuring to get all of these variables at once. Next up, let's actually get our coordinates from this latitude-longitude variable here. So as we see, we expect the data in a format like this. And so that makes it really easy to copy this data from Google Maps. So let me just quickly show that to you, because it's important that you understand how this kind of stuff also works in practice. So let's use the Los Angeles example here. Okay, and so let's say you live somewhere here. Okay, and so you can very easily get the latitude and the longitude like this. Okay, so let's put that here just as an example again. And so this is the format that we expect latitude and longitude. And so let's now create one variable for each of them. So one for latitude and one for longitude. So let longitude dot split, because it's a string and we want to split it by the comma. And so that will then create an array of 2 elements. And now we can again use the structuring in order to save these to the 2 variables that we're interested in. So latitude and longitude. Okay, next up I want to test if we actually have the latitude and longitude variables defined. Because if not, then it means that the user didn't specify them in the required format. So let's say if there is no latitude or no longitude, then we want to create a new error. So as always, new app error, and I'm not sure if we have it actually still right here, and actually we don't. So we commented out this part because we no longer needed the app error after creating our handler factory functions. But now we actually need it again, and so let's bring it back. And the message here is going to be, please provide in the format like this. Okay, and the error code 400 for bad request. Great, and now just to see if all of this is working correctly, let's just log all of this to the console. So the distance, lat, longitude, and unit. And let's also send a generic message here just to really finish the request response cycle. And so that, of course, is the same as always. So status success for now, and then of course later on we will send the data that our query returned. So actually let's copy this here, because this kind of is already what we want. So back in Postman, let's close all of this. This one we no longer need. All right, we also don't need to be logged in, and we also don't want any updates. So anyway, now we also need to get this part, which I'm too lazy to write out. And so let's test that now. And that didn't work. And I think this one we call tours within, actually. Didn't we? So tours within. So I'm not sure why I then wrote distance here. Let's just quickly fix that here in our examples. And so, of course, it's tours within. And that's still not working. So let's take a look at our route implementation here, actually. So here we have that. And yet, of course, this is not correct at all. So this one here should not be inside .route, obviously, but instead it should be in the get method. And so now that looks a lot more like what we have here. So .route and then .get. So one last try, and this time it worked. And let's take a look at our console. And indeed, here we get the distance that we specified, the latitude, the longitude, and the unit. Great. And so now it's time to actually write the query itself. Now, a geospatial query actually works quite similar to a regular query. So we're still going to write to tours is equal to tour.find, and of course, awaiting the result of this promise. And then the old game of marking everything as async and then catch async and wrap our function in there. So we have our tours here unused, and so let's go ahead and add it here to the response object right away. So data, and now remember how we called it data, and then tours. Okay, and now all we need to do is to specify our filter object here. So remember that we want to basically query for start location, because the start location field is what holds the geospatial point where each tour starts. And so that's exactly what we're searching for. So start location, and now we need to specify the value that we're searching for. And for that, we will now use a geospatial operator called GeoWithin. So as always, we need to specify this object. And then here, where we earlier would use like some math operator like greater than, this time we use a geospatial operator like this one, GeoWithin. And this operator does exactly what it says. So basically it finds documents within a certain geometry. And that geometry is what we need to define as a next step. So we want to find documents, but where do we actually want to find these documents? Well, we want to find them inside of a sphere that starts at this point that we defined and which has a radius of the distance that we defined. So again, with our example in Los Angeles, if you specified a distance of 250 miles, then that means that you want to find all the tour documents within a sphere that has a radius of 250 miles. Okay? Makes sense? And so now we need to pass that information here into the GeoWithin operator. Okay? And we do that by defining a center sphere. Okay? And again, I know that this looks quite confusing, but that's why I'm explaining it here step by step. And also in a second, we're going to take a look at the documentation. So the center sphere operator takes in an array of the coordinates and of the radius. And let's actually format the code here to make it at least look a bit easier. Okay, well, kind of looks the same, but anyway, let's now define the coordinates here. And for that, we need yet another array, and then the longitude and the latitude. And that's right, we first need to always define the longitude and then the latitude, which is a bit counterintuitive because usually coordinate pairs are always specified with the latitude first and the longitude first. But I think I mentioned this before, that in GeoJSON, it for some reason works like this. So that is the center of the sphere. Now we need to specify its radius. Now here we actually do not pass in the distance, but instead MongoDB expects a radius in a special unit called radians. So let me put the radius variable here, and then in a second we are going to define it. So let's now actually define the radius. And so again, the radius is basically the distance that we want to have as the radius, but converted to a special unit called radians. And in order to get the radians, we need to divide our distance by the radius of the Earth. So that sounds a bit crazy, but really this is how it works. Okay? And so now actually we need to take into consideration our unit here. Because of course the radius of the Earth is different in miles and in kilometers. And so let's now do a ternary operator here and say that if the unit is equal to miles, well then the result here should be distance. So basically our original radius divided by 3,963.2. Okay? And so again, that is the radius of the Earth in miles. Okay? And otherwise, we will then assume that it's kilometers. And so if it is kilometers, then it is the distance divided by 6,378.1 kilometers. All right? So again, this kind of crazy conversion here is necessary because MongoDB expects the radius of our sphere to be in radians. And radians we get by dividing the distance by the radius of the Earth. Great, so we're almost ready to test this now. Let's just add the results property that we used to have. So with the number of results basically. And then another very important thing is that we actually, in order to be able to do geospatial queries, we need to first attribute an index to the field where the geospatial data that we're searching for is stored. Okay, so in this case, we need to add an index to start location. So let's do that here in the tour model. And so down here, we need yet another index. So tour schema dot index start location. But now we're actually not going to set it to 1 or -1, because this time it is a different index that we need. So for geospatial data, this index needs to be a 2D sphere index if the data describes real points on a Earth-like sphere. Or instead, we can also use a 2D index if we're using just fictional points on a simple two-dimensional plane. Now in this case, of course, we're talking about real points on the Earth's surface. And so we're going to use a 2D sphere index here. So 2D sphere like this. Okay, and so with this, we're basically telling MongoDB that this start location here should be indexed to a 2D sphere. So an Earth-like sphere where all our data are located. Great. And with that, we should now actually be ready to test out our new route. Okay, let's just increase this radius here a little bit, like 400 miles. And so let's see what we get. Well, we get this weird looking error, and I'm not really sure what that is. And so let's take a look. And probably it's something wrong here with the radius, but actually this is a great time to test out our debugger. So I showed that to you a long time ago, but this is a good use case for actually taking a look at the debugger again. So I think we have an npm script for that. Yeah, it's called debug. So we need to now stop this process and then say npm run debug. Okay? So that should open up this nice window. And let's close up all of these files here. Okay, and so we're in our controllers, tour controller. And so now let's set a breakpoint right here. Okay, because at this point we will have all our variables defined, and so we can then take a look at their values in order to see what's going on. Okay, so of course we could have done that with a simple console.log, but in some situations when we have a lot of stuff going on, then it's also nice to use the debugger. So we need to send our request, and now we're in the debugger at our breakpoint. And so at this point in time, our code has really stopped. And we can see here that actually all our variables seem to be defined. Let's take a look at that here in local. And so we have a distance, we have the latitude, the longitude, and also the radius. So let's keep going here. Okay, so we jumped right to the next line, of course, because this if here didn't enter the if block. And so now it's running all of these functions, but let's step out of them actually. And now we actually get tours undefined. Okay, so if we now continue this, we will probably get that same error again. Right? And so indeed, we do. And so it must be something here in this line, let's say. And indeed, I think I found the error. So that's not how you write sphere. So sphere is more like this, right? So I hope and I believe actually that this was the error. So let's actually close up the debugger here. And let's really leave. And actually that should have updated my code here. Let's see. And it actually didn't. So I'm not sure why that is. But all right, let's run this here again. And not this command. Okay, anyway, let's just do npm start. Close all of these. And now try it again. And now we get some real results here. Nice. So it tells me that these 3 tours here are in that 400-mile distance that we specified. But how can we really know if that is true? Well, actually, we can use Compass for this. So if we open up Compass here, we have something really nice, which is this schema. So let's do that here in the tours. And so we can now come to schema here and then analyze the schema. So analyze the schema. And so now here we have a nice summary for all of our fields. So for example, you see that the difficulty is easy in 50% of the documents, medium in 30%, and difficult in 20%. You also see these durations. So in 20%, it's 5, and also 9 is also more popular than the other durations. Now, what I'm really interested in here is the locations, or actually the start locations. So, and that's here. And now, normally you would see a map here, okay? But right now, there is no map because we have a document right now which doesn't have a start location, okay? So in order for this to work properly, we need to get rid of that document. So it was one of these testing documents that we created, but which we now actually no longer need. So let me see if it shows up here, and maybe it's in the end. And so yeah, it's this new test tour. So let's get rid of that. And back to our schema, let's analyze it again. Okay, so here we have the start locations. Oh, and here you already see the map. So that's great, right? That's really a handy feature. So we should have 9 points here. So 1, 2, 3, 4, 5, 6, 7, 8. And one up here, the 9th one. So probably this one is to see the northern lights, right? And now here we can actually replicate that query using this graphical interface. So let's come to Los Angeles and approximately to the point where we were. So let's say here, and I'm zooming out a little bit just to give us some more space. But now we can hit Shift and then drag. So just as it says down here. So put the hand where our point was. So basically somewhere here in Los Angeles. Now Shift and then drag. All right. And so you see that as we start increasing this sphere, we get more and more tours. So more of these points here turning yellow or orange. Okay. And I believe that our radius was something like 0.1. So something like this, let's say. And so you see that actually 3 documents, so 3 tours, fall within this sphere that we just created. Okay, so we have this sphere with a radius of 0.1, as you can see up here. And so in fact, this query looks just like the one that we just built with code in our controller function, right? So we get these 3 documents that are marked as orange. And so let's actually now hit analyze here again. And so now our query returned 3 documents. So let's see their names actually. So where is that? So the sports lover, the wine taster, and the park camper. And the 3 tours that we got in Postman, so as the result of our API, should be these exact same 3. So sports lover, wine taster, and park camper. So park camper. Then you have the sports lover. And the last one, remember, should be the wine taster, and indeed it is. Great, that's really fantastic. Let's now just decrease this here to 200. And let's say how many results we get then. And in fact, it's only just 1. So let's come back to Compass here. Let's delete this query here so that we get back to all our documents. Take a look at our map. And so, here is LA, okay? And so now the radius should be something like 0.05. No, so something like this, let's say. And so indeed, we only get this 1 tour, which is, I believe, the wine taster or something. Yeah, we have to analyze this. So, oh, actually it's the sports lover. And so let's see if that's what we got here. And indeed, it is. So it's the sport lover. And so that is the only tour that is within 200 miles of Los Angeles. Fantastic. So this I find really, really exciting, really cool. So let me just show you another thing very quickly. So we can also see all of our locations on the map. So that's here. And so these are the locations of all of the tours. So the ones that are stored in locations. So we have the coordinates, and we also have the days, description, and the types. Okay. Now, of course, our query is not about all of these here. For that query, we really just cared about the start locations. But I still wanted to show you this map where we can actually see all of the locations as well. Okay. So there really is a huge potential for using geospatial data with MongoDB. The possibilities are really endless for doing geospatial queries like this. And I actually wanted to show you that we have some more geospatial operators in MongoDB. So let's take a look at the documentation here again. So let's come down here again to the reference, then operators, and query operators. And I think that somewhere down here, yeah, so here we have the geospatial operators. And you see that this is the one that we used. So the one that selects geometries within a bounding GeoJSON geometry. So that sounds a bit weird, but this bounding GeoJSON geometry is that sphere that we defined in our code, right? Now we could also have used the near here. Let's take a look at that. And so that would have worked a bit different. So in this case, we would have defined the point using the longitude and latitude that we got, and then we would have specified the maximum distance here in meters. And then in this case, we didn't need to do the conversion to radians. Okay, and what's also nice about this one is that we can specify a minimum distance. And so with this, we could, for example, exclude tours that are only 50 miles away from our starting point. Okay, so if you someday need something like this, then you can always use the near operator here as well. Okay, great. So with this geospatial query that we just defined here, we basically found documents that are located within a certain distance of our starting point. But what if we actually wanted to know the exact distances of all of the tours to that starting point? Well, that's exactly what we're going to calculate in the next lecture.